Hello, everyone. We are scholars at Duke Collaboration Finder using the power of AI team, and today we are super excited to share with you all about our product. My name is Melina, and the other team members are Ali, Rachel, and Yulia. The problem we have identified is that the previous scholars at Duke search system lacks semantic flexibility, is keyword-based only, and cannot compare across profiles. It also it's also true that the funding opportunities are decentralized, so scholars at Duke data is not directly leveraged to help find funding. And developing profiles is time consuming. It's daunting for our users to write overviews and keywords, and that can lead to limited quality of search results. Our solution is Scholars at Duke Opportunities Finder, which is an AI-powered web app that provides non-direct connections for collaboration as well as finding finder, and profile completion features. Our project goals are to generate creative, high-quality matches among scholars, increase access to funding and award opportunities, help scholars with semi-complete profiles, and facilitate the maintenance of scholar profiles. Now I will hand it off to Yulia.
Awesome. Thanks, Melina. So on our back end, I'll highlight that we're using Chroma, which is our big vector database, and we're also using LangChain to facilitate a lot of the LLM work that we're doing. And on the front end, we're using classic CSS, JavaScript, HTML, and then bringing it all together with Fast API. So our website breaks down that problem that we face into 4 key features. So we have the collaboration finder, the funding finder, profile generator, and then we have the search history, which is associated with the collaboration finder. And I'll really quickly highlight what that looks like on our homepage. So here we have, it's actually modeled after the original Scholars at Duke site. So we have our mission statement, and then we have a little carousel highlighting scholar collaborations, hopefully in the future ones that our tool helped arrange. And then at the bottom, we have our 3 key features highlighted: the collaboration finder, funding finder, and profile generator. So before we jump into the technical aspects of the specific features, I want to go over and share some of the ways that we process text data using AI, because these words are going to come up a lot. So one of the things that we have to do is split text into multiple pieces, because we have all of this text data on Scholars, right? And we have to process it one way or another. And there's multiple different ways of chunking that we use. And then after we have those chunks of text data, we need to go through and create vector embeddings. And for that, we use a vector embedding model, or an algorithm that processes that dense information into a compressed form in multidimensional space. And then we have these vector embeddings. And why these vector embeddings are important is because it allows us to make these complex semantic comparisons between our text data. So just to give a simple example, let's say we have a vector representing apple and another vector representing the word banana. And one of the dimensions, so one of the numbers in that vector represents fruitiness. So an apple and a banana will have a very similar number for fruitiness, but if for a chicken, that number will likely be very different. And then going forward, vector database is going to store all those vectors for the scholars that do text data. And another thing that we're doing a lot is LLM prompting. So essentially giving a large language model different types of input. And this can, in our case, look like providing an LLM with example inputs to generate desired output. So jumping right into our first feature, the collaboration finder. Here we have a customizable search. So we have a lot of different types of users on our site, right? So we have delegates, scholars, faculty administrators, and they need to do all sorts of types of searches. So they can search by scholar, profile similarity, custom text query, both. They can access matching data and profiles of suggested collaborators, and then they can do a lot of fun things with the query. I'll jump right into the demo, which shows this in action. So here we have a search getting run. So we're going to search on Melissa K, and we want to find people for her in pediatric care. And we also want to filter maybe by some schools at Duke. So let's say the School of Nursing, Medicine, and Trinity. And then we'll search for collaborators, and out we get matches. So each of these matches has topic areas that are LLM generated, and there's pubs associated from that scholar's profiles with them. And then they can also rename the search. So that they can find in their search history later, look back at who was suggested, favorite the search so it's up top. And here we see the demo search is at the top of our search history. We can go back, delete the search, and then we can also go back and refine the previous searches. And now I'll pass it to Ali to talk about some of the technical background for this feature.
All right, thanks so much, Julia. So just to go into how the collaboration finder search works, as you saw, we have both the Scholar query and the text query. And the first thing we need to do is vectorize those inputs so that we can compare those embeddings to what we have in our vector database. Or the Scholar queries, we either, depending on the strategy we're using, will get the summaries for that specific scholar from Chroma, or on demand generate keywords based on their profile information. Once we have those vectorized inputs, we send those into a query to our database, which will return us a list of the most similar matches. And from there, all we have to do is categorize those results by each individual scholar and by the text type. We then rank the scholars by their average similarity so that we can return the top matches to our users. And in terms of how we're embedding all of our text, we have a couple different methods going on. We have 5 methods: standard loading, 3 types of chunking, and summarization. So in those processes, what we're doing is obtaining scholar data from the scholars database, specifically their overview text and publication abstracts. For the standard loading, we're just taking those pieces of text directly and embedding them straight away. For the chunking strategies, like Yulia talked about before, we're splitting the text based on different criteria. So that could be length, meaning, or other ways of tokenizing a specific piece of text. And for summarization, that involves prompting an LLM to generate the research topics and matching these summaries to a handful of publications that best reflect that area of expertise. So all of these strategies have their strengths and weaknesses. For the standard loading, this is, of course, the truest to the scholar's actual work because we're not processing the text at all before we're embedding it. It's just the text right away. But this does mean that a large piece of text needs to be reduced down to a single vector. So if you have a publication abstract with multiple paragraphs touching on a couple different ideas, then these can lose their complexity once we try to narrow them down just to one string of numbers. For chunking, these strategies fare pretty well with the text queries because it does preserve the actual text, but it is chunking them into smaller pieces that are kind of losing some of that context that can really be useful in terms of interpreting the results and identifying what are the most relevant matches for each scholar. For summarizing, this strategy fares pretty well with the scholar queries because it zooms us out a bit more to look into the specific areas that a researcher is interested in and gives us more of a broad view of their research as a whole. But this does mean that there is some overgeneralization, and users who are looking for a specific query, a specific field of expertise, it might not be represented in a scholar's summary and therefore not return them as a match. All right, so now our search history, we really wanted to prioritize this feature because we wanted to make sure that users really had access to all of the matches they have at their disposal. We make sure that they can really customize their experience and even rerun searches again to see if they get different results depending on the different strategies and the different fields the database is currently at. So to implement this, you just have a simple SQLite table. We have searches and users, and these are auto-populated when users log in or when they make searches. And as you can see, we have the variables defining the different just helpful features that we can utilize to help scholars find out exactly what they're looking for. All right, so now I will pass it off to Melina to talk about our funding finder.
Thank you, Ali. Our second feature is a funding finder that directly connects to Duke's research funding website. The user can input a scholar's name, which gets auto-completed, as you've seen. We then take their profile information to identify corresponding topic areas to be selected as filters as they get redirected to research funding website. Here's a quick demo of this feature. We'll go ahead and select it, input the scholar's name. Some context about this person is that they do brain studies and neuroscience, I believe. And here's a guideline on how research funding website works. And once you hit find funding, you will be redirected to that website. And we can see that those filters are indeed representative of what the scholar does. Okay. From a more technical standpoint, here's how we generate keywords. We extract overview, publication titles, and department names using REST API and GraphQL, and then we process them. This includes normalizing by removing punctuation, one-letter words, or other words that don't really carry a meaning for our purposes. Lemmatizing by reducing words down to their root to avoid repetition, and categorizing them by counting the number of times each word occurs. And then we return the list of most occurred words as nouns as the keywords that can then be copied and pasted and used into completing their profiles. In terms of the filters, we pass previously explained keywords and a list of all topic areas extracted from Research Funding API to our LLM and have it identify which ones are most relevant. Once we have those, the URL is modified so those filters are selected, and then the user gets redirected to that link as we saw on the demo. Now I will hand it off to Rachel to go over our last feature.
Thank you so much, Melina. The third and final piece of our project is the profile generation feature, which is mainly geared towards helping those scholars who do not necessarily have as much information entered into their profiles. The more data that a scholar's profile has, the more accurate our information and results will be. The profile generator aims to help solve that problem by using the autocomplete scholar search to then generate keywords and an overview for a given scholar. So this is a short demo of the feature. You can see that it's found in the bottom right-hand corner of our homepage. And by looking up the scholar's name, in this case, we're going to go with Professor Andrews. Our feature will then generate keywords and an overview related to, in this case, her existing work in linguistics and neuroscience. And this can then be manually copied and edited if they want to change it, and then easily uploaded to their scholar's profile. On the technical side, the text is generated by using an existing overview if the scholar already has one, and their research abstracts that we already have, and then we prompt the LLM to synthesize and summarize that information into a new overview that can be manually edited and added to their scholars' profiles. Looking forward to the future, we hope to continue working on the project to make it run more efficiently and operationally. We also hope to do more user testing with people who would actually find our product helpful, like scholars, delegates, and faculty administrators. We would also like to do some quality testing by comparing some of our search outputs with previously asked questions to administrators. Finally, we also hope to compare different NLP methods, like Ali talked about earlier, and LLMs for different website features. We'd like to thank our stakeholders, the Crux team, the Collab, OIT and Research Computing, as well as Jen and Isabel and our team leads, Eric and Richard, and Dr. Reifschneider, as well as the broader Code Plus community for helping us learn and grow throughout the program.